In this chapter, we'll be covering class attributes and methods. So what are attributes? So data members of the class are called attributes or properties. Java supports use of primitive data types as well as classes as data members. When we use primitive data types, the default value for them would be 0. When we use classes as data members, the default value for them would be null. Within the body of the class, any non-static methods can refer to the data members using this keyword. It is not mandatory, but in some cases it is required just to distinguish the formal arguments from the data members. We'll take a look at the example in detail. Here you can see we have declared playing ball as the class. In that we have highlighted the data members. So type is a data member and its data type is string class. Radius is a data member and its type is int. So type will be assigned null since it is a class, and radius will be assigned 0 since it's a numeric data type. Now we have a method. This is a non-static method. We are referring to the data member as this.radius. We can also refer as just radius without this. But it is a good practice to use this keyword when referring to data members. Now why this will be important is, let's say we have a method which takes a formal argument whose value is also radius. In that case, we need to distinguish the formal argument from the data member to avoid conflict. Same thing here. In this method is basketball. We are referring to the data member type using this keyword. So what are methods? So methods defined in a class serve one of the following purposes. They can be used to access data members. They can be used to set the data members. Methods can also exhibit behavior. So they give a behavior to the class. When we want to declare a method, we must specify the return type. If there is no return type, then we have to mention void. So void is a keyword. There may or may not be parameters to the method. Now within a class, method can have same name. So naturally this is going to bring a question in your mind. How can we refer to methods with same name? So the answer is straightforward. They need to differ by the argument types, the number of argument types and the data types. So we'll be looking in deep with the example on this. So here is a playing ball class. We have declared two data members, type and radius, as we discussed in last section. Now here we are having a non-static method volume. As you can see, the volume method is returning an int. So we need to mention that it is returning an int. So this is the return type. Also you can see that the volume method is not taking any argument. So that is the reason there is an open brace and close brace, and it doesn't have anything. So we'll be looking at a demo example in a short while. So if data members are declared, how can we use them? So let's take at rules governing them. So for any non-static data members, to be accessed from non-static methods or code, we can use this dot data member, and if it is method, then we can say this dot method name. As we discussed earlier, this keyword is not required, but generally it is a good practice to avoid conflicts. If you want to access the static members from non-static methods or code, we can directly use class name dot data member or class name dot method name. Here too, the class name is not mandatory, but generally it is a good practice so that the code is more readable. Now, from within static methods and code, we cannot access non-static data member. So Java would not allow this. It is an error to access non-static data members from static method or code. Now, what about the case where we want to access the non-static data members from outside? So when you say outside, which means outside of your class. So in this case, we have to create an object of that particular class and use object reference dot data member, object reference dot method name if it is a method with appropriate arguments. To access the static members from outside, you'll use the same convention, class name dot data member and class name dot method name. So here is an example. So we have playing ball and we are creating a variable b1 and we are assigning it a new instance of playing ball. Now here we are doing b1 dot type. So we are using the object reference b1 to access the data member type, and we are assigning football value, football string to it. Similarly, we are accessing radius and assigning value 8 to it. The last line, we are having result as boolean and we are calling the method is basketball using the object reference b1, and the result of this is a boolean that we are assigning it to result variable. So what is method overloading? So as we briefly mentioned, one or more methods can have same name, and if that is the case, they are said to be overloaded methods. Now the criteria to overload that is that they must be unique by their signature, excluding the return type. And we'll see with the example what it means. So here is a sample class, test class, and we have tried to declare some methods. And you can see all of them have the same name. Now the first one is void method 1, and then there are no arguments, and then it has some implementation. Then we have int method 1, then it has some implementation. As you can see, the signature of the method 1 and this method 1 is same except for the return data type. Now this will give us an error because the method signature has to be unique excluding the return type. When the compiler looks at overloaded method, it will discount the return data type and see if the rest of the method signature is unique. So in this case, this method 1 is same as the first method 1, hence it is going to flag an error. Now the third case, we have method 1 which is written in int and it is taking one extra argument. So there is no error with this. The fourth case, we again have method 1 and we are exactly using the same argument int x. So it is of type int. So hence it is going to conflict with the third case. So it is going to flag an error. In fourth case, we have method 1 int x int y. So number of arguments is different, hence it is unique, it is okay. In the next one, we have method 1, int x float y. You can see here the number of arguments are same, but the data type is different. So here there is no error. In the last one, we have method 1, int x string y. So here number of arguments is same, but the data type of the second argument is different. So hence it is not an error. Let's take a look at sample demo program. This is our demo example. We have playing ball class. In here we have two data members. One is type and one is radius. And we have two member methods. One is volume, which is returning an int, and another is basketball, which is returning boolean. There is one more data member that we have defined, which is static. We'll discuss more about what is final later on. And here we have assigned it a value of 9. Let's take a look at how we can use it. Now we have defined one more class, playing ball demo. In here it has a public static main, and in this we are going to use the playing ball. So now let's create an instance of this and see what is the default values. So we have the code snippet, so looking like this. We are creating an instance and we are trying to see what is the value of pb radius and pb dot type. So if you run this, so here you can see the radius is 0 and type is null. So as we had mentioned, numeric data types are going to have a value, are going to have default value as 0, and data types which are of type class will have a value as null. Now let's try to create one more instance. So we have pb2, which is new playing ball, and now we are assigning some value here. So pb2 dot radius is equal to 8 and pb2 dot type is equal to football, right? And we are going to print this. As we know, the make was a static, so hence we don't need the reference pb2 or pb to invoke that. We can use directly the class name dot the, the data member name. So now if you try to run this, you can see it is showing us the radius and the type football that we have assigned, and the make of the playing ball is Nike. Let's now try to see if we can invoke the functions. So before that, let's introduce the line separator so that visually it is very clear. Now here we are going to invoke the volume method and try to see what is going to be the volume. So in here we are doing pb.volume, and in the second case we'll use pb2.volume. So now we have the volume also being printed. Let's try to invoke this and see the result. So here you can see that it is printing the volume as 0 in the first case, the radius is 0, and in the second case we are having a volume of 2145 as per the formula. Now consider a use case where we want to find the largest playing ball. So here is the code snippet for that. So we have the method find largest. We are passing another ball, so playing ball other, and we'll be comparing it to this instance. So which is why we are using this dot radius and comparing with other dot radius. So here we are using a ternary operator. You can see that if this dot radius is greater than other dot radius, then we are returning this. Otherwise, it is returning other. Consider a use case where we want to find the largest of the playing ball when there is an array. I want to introduce a snippet of code to find the largest from the array. So first we have declared largest to be this, so that is the current element. After that, we are iterating using the for loop through the array. You can see we are comparing the current largest, which is starting from this, and it is comparing against the next element in the array, and it is assigning the value back to largest, and then it is returning the largest. Now let's try to create a couple of more playing balls. Now try to see the result of this. So let's do a system out. Basically, we are trying to find whichever is the largest, and then from the largest we are just printing the type, right? So now same thing we can do for PB, let's say 1, PB2 and PB3, and here we can pass PB. We'll invoke find largest on PB2, and let's define playing ball array, and we can now call the overloaded method, which is taking an array, and we'll try to find what was the largest. So PB versus, so find the largest, and here we are going to pass array1, right? So now let's put a line separator in here, line separator in here, and this we don't need. Yeah, this should do the job, and if you try to run this, let's see what the result is. So now we are comparing PB and PB3. So within PB and PB3, which is the largest? So X ball, which is having radius as 1, so it is comparing with 0, so naturally this is the largest, so it is printing that one. And for the comparison of PB2 and PB3, PB2 is having a radius of 8 and PB3 is having a radius of 1, so in that case the football which is having a radius of 8 is the largest. Now when we compare PB to all others, we can see it is printing Y ball. So Y ball has the maximum radius, it is printing Y ball. So as you can see, we have given a demo of overloaded method. So the GRE is appropriately calling the correct find largest. Is this one is appropriately referring to the one which is receiving array as the argument, and the other one are referring to the method which is receiving playing ball as the argument. Let's do a quick recap of class attributes and methods. The data members of a class are called attributes or properties. Data members allow to store the state. Methods allow to access or set data members. Methods also give behavior to the class. Methods can be overloaded. It's a good practice to refer non-static members using this keyword. It's a good practice to refer static members using class name.